Hello everyone, welcome to the audio tutorials on engineering mechanics. Okay, so now the lecture 6, which is again on example problem for finding the resultant of forces. Okay, so now the problem is given like this. The two forces 260 newtons and 200 newtons act on a particle or on a body as shown in figure, and calculate the magnitude of resultant using parallelogram law of forces and resolution into components. So that means by using two methods we are going to find out the resultant of the two forces. Those are 260 newtons and 200 newtons acting on a body at certain point here. So first I want to represent the figure. With reference to the figure we have to solve the problem. So this is the figure. The 260 newtons and 200 newtons are acting on a particle at certain point. We can assume this intersecting point as O. Okay, so on that O point we assume the two forces acting with an inclination 30 degrees to the horizontal line, and 200 newtons is also acting 30 degrees inclined to the vertical line. Okay, so with reference to the horizontal line and vertical line, the inclination angles are given. So by using this information we need to draw the resultant force acting on a body due to these two forces. That means here we can represent these two forces by a single force. That force is the resultant force which is acting on a body, so with the effect of these two forces. So the first method he asked to find out by using the parallelogram law of forces. So in parallelogram law of forces there is a direct formula for finding the resultant of two forces which are acting at a point on a body. So already we have discussed the derivation. If you don't know the derivation, if you don't know the formula, please go through the previous videos. In that you can find out the derivation of parallelogram law of forces. So by using the parallelogram law of forces, now we are going to find out the resultant force for the two forces 260 and 200 newtons respectively. So assume first P is 260 newtons. So the first force 260 newtons I am representing by a letter P. Okay, so in this again the 200 newtons I am representing by using Q. Okay, so next the inclination alpha, that is the alpha is 150 degrees. So 150 degrees, alpha is 150 degrees. Why it is 150 degrees means, uh, so here by the parallelogram law of forces, here we need to assume these two forces are the two adjacent sides of the parallelogram. So when you consider these two forces as the two sides of the parallelogram, so the angle between these two forces, that means these two adjacent sides of the parallelogram, becomes 90. This one is 90 plus 30 plus 30. So total how much it becomes? So 90 plus 60, it becomes 150. So the alpha is the angle between the two forces, that is 150 degrees. So that means the angle between the two adjacent sides of the parallelogram, here it is 150 degrees. So here the formula, by using the formula directly we can find out the resultant force. Okay, so the resultant force can be written as r square is equal to p square plus q square plus 2pq cos alpha. So here p force, q force and 2pq cos alpha is the angle between two forces, that is the angle between two adjacent sides of the parallelogram. So by substituting the values directly we can get the resultant force, which will give the same effect as the two forces 260 newtons and 200 newtons. So now substitute the values. R square is equal to p square means 260 square, and q square means 200 square, plus 2pq means 2 into 260 into 200 into cos alpha. Alpha is 150 degrees. So substituting the values, please calculate, simplify by using the engineering calci. So you'll get the values like this. R is equal to square root of same thing, and here I am representing the 260 square plus 200 square minus 2pq cos alpha values. So by square root of these values, R is equal to, will get 132.4 newtons. So this is the answer, which will give the same effect as the 260 newtons, 200 newtons acting on a body. So that is the resultant force of two forces acting on a body at certain point. Okay, this is the way of finding resultant of two forces which are acting on a body by using the parallelogram law. So here two forces only are acting, so because of that we have assumed these two forces as two sides of the parallelogram law. Then we have solved the problem. Okay, in case of three forces, if they are acting, then we have to use the resolution of forces into components. So that is the second method we are going to discuss for the same example. So next thing is resolution of forces. By this method we need to find the resultant of these two forces. So resolution means we can uh, we can resolve one force into two components, that is horizontal and vertical. So the P can be represented divided or resolved into a horizontal component, that I am assuming PH, and it can be again resolved into vertical component like this, I am assuming PV, and similarly Q also can be resolved into two directions, that is in horizontal direction QH and that is in vertical direction and QV. So first we need to write the what is horizontal component values and what are the vertical component values for P and Q both respectively. Okay, so now the force we have already assumed P is equal to 60 newtons. So for this we need to write the horizontal component of P, that is PH. So that PH can be written as P cos 30 degrees. Why it is P cos 30 degrees means here this PH is horizontal line and this one is hypotenuse, we can assume. If you shift this PV perpendicular to the PH, then it can become a right angle triangle. So with respect to the right angle triangle, we can write cos 60 is equal to, sorry, cos 30 is equal to PH by P. Okay, now by forming right angle triangle here, we can write cos 30 is equal to PH by P. So the PH can be written as P into cos 30 degrees. Okay, so that is the horizontal component. Remember, PH can be written as P cos 30 degrees. Horizontal means here you'll get cos component, that is P cos 30 degrees. Okay, so what is the value? Whatever the value you are getting, write down the value that is related to the horizontal component of P. Similarly, we need to find the vertical component of P, that is PV. So the PV, for writing the PV we need to take the sine rule. For the same right angle triangle here, by using PH, P and PV, we can write sine 30 is equal to PV. This PV for right angle triangle here we assume. So this PV into P, that is sine 30 is equal to that is opponent by hypotenuse. Opponent is PV and hypotenuse is P. So the sine 30 is equal to, we can write it as PV by P. So PV is equal to, we can write it as P into sine 30 degrees. So again substitute the P value. P is equal to 260 into sine 30 degrees. So whatever the value you are getting by using the calci, find out the value, that is I got here 130 newtons. Okay, so that is the vertical component of P. So the horizontal component and vertical component for P force is over. Next we need to find out the same thing for the Q component. Okay, so for, sorry, Q force 200 newtons. So for the Q, again Q is equal to 200 newtons. In this we need to find the horizontal component QH. So here this QH, this one is the horizontal component. So if you shift this QH to this here, so this QH becomes here opponent and this Q becomes hypotenuse and QV becomes here adjacent. So in this case QH, for writing the QH we need to take the sine rule here. So the QH is equal to, will get Q into sine 30. So why? Because here QH is becoming, sorry, QH is becoming opponent here. So sine 30 is equal to QH by QV, sorry, QH by Q. Okay, now QH by Q sine 30 is equal to QH by Q. So QH is equal to, we can write it as Q sine 30. So the Q is equal to 200 newtons, already we know. So substitute the 200 value, then we'll get the desired QH. And similarly the vertical component is QV. So that QV will be obtained by applying the cos 30 rule or cos theta rule. So here QV is equal to, will get Q cos 30. Why? Because cos 30 is equal to, we'll get QV by Q. So QV is equal to, we can write it as Q cos 30. So Q value is 200. So then substitute 200 value, 200 into cos 30, we'll get the value related to the 200 cos 30 by using the calci here. So by using the calci, get the value QV also. So in this case again we have determined the two components of the P and Q. So by finding two horizontal and vertical components for P and Q, then we can find out the resultant force. The formula for the resultant force is uh, square root of sum of the horizontal forces plus sum of the vertical forces. So here first we need to find out the sum of the horizontal forces, that is sigma h. So first find out, before finding the resultant force, again we need to find out the sum of the horizontal forces for P and Q. In P and Q, two horizontal forces are there. So take the sum. So pH is 225.166. You got here 225.16. So pH is 225.166 minus and 100. This 100 is related to the horizontal component of the Q. Here the horizontal component of the Q, you got 100 newtons, and we have taken negative sign because this QH is acting opposite to the pH. Okay, pH is acting in x direction, and QH is acting in negative x direction, so that's why pH is positive and QH is negative. So similarly we got here 225.166 minus 100. Okay, so according to the direction in x direction and negative x direction, and y direction in negative y direction, we need to take the negative sign while getting the sum of the forces. So here this one is the sum of the horizontal forces, will get the value as 125.166. Next we need to find out sum of the vertical forces. So sum of the vertical forces means we need to consider the vertical component of P and Q. So first the vertical component, here we represent sigma V as the sum of the vertical forces. So PV is 130 newtons and QV is 173.2 newtons. So here again we have taken PV as vertical negative, because PV is the vertical component of the P which is acting downwards. Downwards means it is negative y direction. So that's why we need to take the negative sign. And similarly QV is acting upward. Upward means in positive y direction, so the positive means we need to take the positive value. So by calculating these two values by using the calci, you will get certain value that is equal to 43.2 newtons. So some of the horizontal forces, some of the vertical forces related to the P and Q we have determined. Next we need to go for the resultant force, that is R is equal to square root of sigma h square plus sigma v square. So substitute the values here. Square root of 125.166 whole square plus 43.2 whole square. Next simplify by using the calci, you'll get the value 132.4. So compare the values, whatever the value you have got by using the parallelogram law of forces, by the resolution of the forces, both should be equal. If both are equal, the value you have determined is correct one. If you are getting any different value by the two methods, that is wrong. Okay now, so by using the two methods, the resultant value should be equal, then only the problem is correct. Okay, so this is the way of finding the resultant of two forces acting on a body by using the two methods, parallelogram law of forces and resolution of forces. So I hope you understood my explanation for finding the resultant of number of forces acting on a body. So we have taken only two forces. In next class, in next video, in next tutorial, we discuss to how to find out the resultant of number of forces, more than two forces acting on a body. The resultant of number of forces, that is more than two forces acting on a body, how to find the resultant of those forces, we discuss in next video. So again, thanks for watching my video. If you still have any doubts, please feel free to give a comment to my video, so that I will try to clarify your doubts. And please don't forget to subscribe to my channel and follow my channel. And my request is, while starting the video, whatever the ads you are getting, please click on the ads, so that could be helpful for me. So thank you so much again. Thank you all.